Welcome to solverfy.
For part A, let's predict the type of reaction that dopamine is most likely to undergo in water. Dopamine will undergo an acid-base reaction in water as dopamine contains an amine group which has a lone pair of electrons on the nitrogen which accepts a proton from water to form NH4 plus and OH minus ions. So if we look at the reaction, this will produce this will act as a base, this will act as an acid, this will act as an acid, and this will act as a base. So we have an acid base. It's actually a Brownstedt-Lowry equilibrium here that results. For part B, we're told that if we take 400 milligrams of dopamine per 250 milliliters of solution, what is the concentration of dopamine in the IV bag in units of molarity? So let's first solve for the moles of dopamine. We have 400 grams of the dopamine, 400 milligrams of the dopamine. Let's go back here. Milligrams. And so let's convert this to grams. And dopamine has a molar mass of 153.3 grams per mole. And this will give us 0.00261 moles for the dopamine. And we can solve for the molarity of the dopamine, which would be equal to the 0.00261 moles divided by the volume, 250 milliliters, converted to liters, and this would work out to 0.0104 molar. For part C, we have an experiment with rats. How many molecules of dopamine would be produced in a rat if the average brain volume is 5 millimeters cubed? After 60 seconds of this dose, we're told that the molarity of the dopamine is going to increase by 75 micromolar, which is equivalent to 75 times 10 to the negative 6 molar. We're told that the average brain volume is 5 millimeters cubed. Let's convert this into liters. I know that there's 10 millimeters in 1 centimeter. That'll be cubed. 1 centimeter cubed is equivalent to a milliliter, and 1,000 milliliters in a liter, and this would give me 5.0 times 10 to the negative 6 liters. Now we can solve for the moles of the dopamine, which would be equal to 75 times 10 to the negative 6 molar times 5 times 10 to the negative 6 liters, and this would be equal to 3.75 times 10 to the negative 10 moles. And now molecules, 3.75 times 10 to the negative 10 moles of the dopamine. 1 mole, 6.02 times 10 to the 23rd molecules, and this would be equal to 2.3 times 10 to the 14th molecules of the dopamine.